So I want to find the formula for a partial sum of a geometric sequence. And to do that, we're actually going to do it in theory before we do it in practice, because I think if we do it in practice, it turns out that it's kind of hard to see it, and it can be kind of tough to see where we're going. So let's take a look at this thing in general. So if I have a geometric sequence, it's going to start with A1, and then the next term, I'm going to add this up with A1 times R, where R is our common ratio. Well, then I'm going to take this second term, this A1 times R, and multiply that by R. Well, that's, of course, just A1 R squared. And then if I take this term and multiply that by R, it's going to be A1 R cubed, and so on and so forth. And let's, we actually want to go all the way up to A1 times R to the n minus 1. Okay, so when we have a situation like that, what we want to notice is that there are, in fact, n terms. Not n minus 1. There are n terms, because on this very first term, it's essentially r to the 0. So it's kind of like we've started counting from 0. And if you count from 0, 1, 2, well, that's actually 3 numbers, even though you're only going up to 2. Okay, so in this case, it's 0, 1, 2, 3, all the way up to n minus 1. That's n different terms. And that is probably like the biggest confusion that I see in this unit. Just take a second and pause and remind yourself that, okay, it's a little tricky. Let me think about it for a second, and you'll be okay. But, take a pause when you need it. Okay, so we're going to call this thing S, and we're going to try to create a formula for S using A1, R, and N. All right, here we go. So I'm going to subtract A1 from both sides, and we're going to get S minus A1 is equal to A1R plus A1R squared plus A1R cubed plus plus A1R to the n minus 1. No big deal. All we've done is move that first term over. But then what we want to notice is that everything over here has R as a factor. So we're going to factor out an R. Now you might be standing there being like, well, it also has A1 as a factor, and that's true, but that doesn't work for what I'm trying to do here. So we're going to leave it for a second. Let's factor out an R. So, sorry, that was the erase button. I want the draw button. So this is going to be R multiplied by A1 plus A1R, because I'm just factoring out an R, so the powers are all going down by 1. A1R squared plus plus A1, oops, there should be a 1 there, A1R to the n minus 2, because it's 1 less than n minus 1. And what we want to recognize is that this whole thing in parentheses, this whole thing is really, 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 really similar to this whole thing. Nope, sorry, this whole thing at the very beginning. This whole thing up here. Except it's missing this term. It's missing this term. So what we can just say is that everything in here is just equal to S, but minus A1R to the n minus 1. Okay, so I'm going to do this. You should definitely pause me and look at this. But this is going to be R multiplied by S minus A1R to the n minus 1. Okay, it's missing that term. That should be a 1 right there. I'm pausing on my own, though of course you can literally pause me with the buttons on your video controller, YouTube thing, whatever. So, I'm not old, you're old. So, S minus A1 is equal to R times parentheses S minus A1R to the n minus 1. Okay, saying that out loud is really bad, but looking at it's not too bad. We're just going to try to get the S terms together. We're going to try to figure it out and solve for S. So, here we go. S minus A1 equals RS minus, R times A1R to the n minus 1 is just A1R to the n. should check that, make sure that makes sense to you, but we're multiplying this thing times that. It's just going to raise this power by 1. Well, n minus 1 plus 1 is just n. All right, excellent. Let's now add a 1 to both sides and subtract rs from both sides. So hopefully this works. S minus rs is equal to a1 minus a1r to the n. So I did do 2 algebra steps in one there. I added this thing to both sides, so it goes away from over here, ends up there. Subtracted rs from both sides. There it is. And we're just about done. We're really, really close. We can write s times 1 minus r, we're factoring out an s, is equal to a1, 1 minus r to the n. So just factoring out an a1 from both sides. Yes, factoring it comes up yet again. But it's not even the hard quadratic, 3-term factoring. It's just 2 terms. And we're going to divide both sides by 1 minus r. And so we get s is equal to a1 times 1 minus r to the n, all divided by 1 minus r. It's a really surprising formula, I think. Like, it doesn't feel intuitive at all, but it is a really useful thing. And since this video is, pushing 7 minutes at this point, we'll stop here. The next video we'll do a couple of examples, but go through this one, make sure this proof makes a little bit of sense to you. That said, if the proof doesn't make sense to you, all you're really going to have to do is apply it. And so, I would want it to make sense to you. That's the fun math of it. But let's get some applications and see if we can make that happen.